Okay, so now we look at this kinetics practice. Okay, so we have this rate of reaction between S2O8 and I minus. All right, when we use thiosulfate to study the rate of the reaction. Okay, so you can read the whole question, and then they ask which statement about the above reactions are actually correct. Okay, actually all three are correct. Yeah, I think the tricky part here is, right, you must observe that the experiment 3, right, the total volume is actually 25 cm cube. All right, so when you compare experiment 1 and 2, you will realize that when the volume of I minus increased by 1.5 times, right, the rate is also increased by 1.5 times. So order for I minus is actually 1. Okay, so if you compare between experiment 1 and 3, when the concentration of S2082 minus is doubled, all right, why can we say the concentration is double? Because the volume is half, right? Okay, so despite the fact that this looks like it's the same, right? But because the total volume is half, the concentration of the S2O8 doubled. All right, then the rate of reaction is also doubled. Okay, so option 2, right, say the rate of reaction, rate of formation of iodine in experiment 1 is 1.79 times 10 to the power minus 5. So we're just going to calculate that, plug in all our numbers, and calculate the rate of I2 formation. Okay, so both iron 2 and iron 3 can be catalyzed. We have gone through that in the last part 9 of your kinetic lecture. So we already know that that is true. So option D is our answer. Okay, question 2, reaction between A and B has a rate constant as stated. Which one of the following is a possible rate equation? Okay, so we're going to just base it on the units. So we can just work it out and we can deduce the rate equation. All right, so basically the rate, right, is actually mole per dm cube per second. All right, so this can cancel out one of the concentration. You just bring this mole per dm cube square, you bring it over to the left hand side, and you will be able to get this units. All right. Okay, question 3, half-life of first order gaseous reaction is 20 minutes. 1 mole is put in the sealed vessel at pressure P. Which one of the following will be correct when 87.5% of X2 has been converted to X atom? All right, so you have X2 converting to X atoms. All right, so 87.5 is equivalent to 7/8, which is 3 half-life. All right, so remember for your product, right, you start from 0, right, and then you go half, and then you go 3/4, and then you go 7/8. All right, so that is basically 3 half-life. Okay, so since your X2 has been converted 0.875, twice the number of X atoms are formed. So that gives this correct. Earlier on, 3 half-life, per half-life is 20 minutes, 3 half-life 60 minutes. So total number of gaseous molecule is 1/8 times plus 2 times 7/8. So total is 15/8. All right. So this one is quite straightforward. Question 4, right? So we have X, Y, and Z. Each of the reactants are varied, the other two kept constant. Which rate equation represents the experimental result? So answer is C. The graph on the left shows that the order with respect to X is 0. All right. So we are monitoring X. You can see that it's being used up over time, straight line. And as Y doubles, right? You can see as Y doubles, the rate is increased by 4 times. So rate with respect to Y is 2. Then the graph on the right shows that the half-life for Z is constant. All right, half-life for Z is constant. So that's why the order is 1. Okay, so let's look at question 5. So we have an energy profile diagram of a reversible reaction between M and N. Which of the following statements are correct? Activation energy is E1 plus E2. That is fine. All right. Rate equation of the reaction is K M and N square. Is that correct? All right. So if you look at step 1, right, the only thing that reacted is 1 mole of N. There's still 1 of the N that is unreacted. All right. So this square is actually wrong. Okay. The equilibrium Mn2 increases as temperature increase. Okay. So as this is the endothermic reaction, right? Option 3 is correct. Okay, question 6. Acid catalyzed reaction. It was found that the rate equation is as given. Concentration change of Y2, right, is measured by a calorimeter. Graph A is obtained when concentration of H plus is 0.1. What is the overall order of reaction? Since Y2 is a straight line down, is 0 order, and we compare graph A and B, right? Order with respect to H plus is actually 1. All right. So the overall order is 1 for H plus. So if it's 1 for H plus, 0 for Y2, 1 for X, the overall order is 2. Okay, so question 7, what could be a suitable value for X? We cannot use 40 because then it will be the same totally as your experiment 2. So we use 10 so that total volume is half. Then at least we can compare, right? Okay, question 8. Lead is the final product formed by a series of changes, radioactive decay of uranium. Okay, this radioactive decay, right, is the first order with, wow, half-life is 4.5 and 10 to the power of 9. What will be the age of a rock sample? Originally lead-free, in which molar ratio is now 1:7. Okay, so for lead to have a mole ratio of 7:1, right, it has to go through 3 half-life. all right, which we have actually explained earlier. Okay, question 9. Decomposition of hydrogen peroxide is a first order kinetics. Certain solution undergoes complete decomposition to liberate 96 cm3, beg your pardon. It is found that 25 degrees Celsius, right, 48 cm3 of oxygen was collected in 35 minutes. How long will it take for 80 cm3 to be produced? Okay, so this question is involve a lot of working. So 0.008 mole of peroxide will form 96 cm3, which is 0.004 moles. All right, 80 cm3 of O2, right, which is 0.00333 moles, will give you 0.00667 moles of peroxide used, which means that there will be 0.00133 moles of peroxide left. Okay, so we plug all those numbers into our formula. We realize that the number of half-life is 2.585. We will need to multiply that by the half-life. All right, so then it will give us about 90.5 minutes. All right, one half-life is about 35 minutes. Okay, so we multiply 35 by 2.55, we will get answer B. Okay, last question. A rock sample was found to contain isotope T and U, which are radioactive. Initially, the ratio of the number of atoms of T to U is 1:16. Then after first order kinetics, half-life of T is 12, U is 3. Okay, so how long will it take to reach a molar ratio of 4:1? Okay, so this question is really kind of like a math question, right? So you just form the equation for T and you form the same equation for U, all right? And we divide equation 2 by equation 1. We realize that it is N is equals to 2 days. N is equal to 2, sorry. And the number of days basically is 12 times 2. All right. So this set of calculation, you probably take a while to understand it. So take your time to pause and look at this explanation. All right. So with that, we end off our MCQ series for kinetics. Thanks for watching. I'll catch you guys next round.